Hi there, Mr. Dell, with you to look at CPM CC2, section 3.2.5, number 3-84, specifically looking at problems that are dealing with multiplicative inverse or reciprocal. So they want us to find that multiplicative inverse, or we can also call it the reciprocal of each of these numbers below. So I'm going to rewrite the numbers so we can see it clearly. A is 7/13. So what would be that reciprocal of 7/13 or the multiplicative inverse of 7/13? Well, the thing is what you're looking for is a number that when multiplied to it, the product becomes 1. That's the idea of a multiplicative inverse or reciprocal, is a number being multiplied to another number and their products are 1. Okay, so how do we do that? Well, if we think about what that means, is I'll show another example. If I were to say I want to take 1/3 and multiply it by, well, a number that then their products is 1. Well, 1/3 of 3 is 1, right? 1/3 times 3 is 1. And if you think about 3 could be written as 3 over 1, couldn't it? So 1/3 times 3 over 1 is 1, right? When you multiply the fractions, I'll go one more step in between. 1/3 times 3 over 1 is 3 over 3. When you multiply the tops, the numerators, and the bottoms, the denominators, 3 over 3, which is equal to 1. So that being said, if you think of this pattern here, 1/3, 3 over 1, they are flip-flop of each other, if I can use that term. That's the reciprocal or multiplicative inverse. So here I would say 7/13 times 13/7, that's what's equal to 1, right? When I multiply these, I'm going to have the exact same number. 7 times 13 is equal to 13 times 7, right? So I have that 91 over 91. When I take these two multiplied, I get 91 over 91 when I multiply those across, which is equal to 1. So that for A, I know I went long there, but A, the inverse or multiplicative inverse or reciprocal is 13 over 7. Okay, so for B, 1/5. So again, what do we get? How can I get that to equal 1? I would multiply it by 5 over 1. Because 5 over 1 times 1 over 5 is 5 over 5, which is equal to 1. So really, for B, our answer would be 5 over 1, or we can honestly just say 5 is the answer for B, because 5 over 1 is the same thing as just 5, right? Okay, so that's B. Let's look at C. C, I want to know, what about for number 2, for the number 2? For the number 2, again, what times 2? When I multiply times 2, I'm going to get 1. Well, this is where we want to, usually it's a flip-flop, right? It's taking a fraction and reversing the numerator and denominator. So I need to take a whole number then and put it over 1 first, make it into a fraction form. 2 as a fraction is 2 over 1. Now I can see, flip the numerator and denominator to be 1 over 2. So my multiplicative inverse or my reciprocal is 1/2. Okay, and then D, this one is 2 5/8. Well, I have a mixed number. To get the reciprocal of a mixed number, the first thing I have to actually do is convert this to just be in fractional, a single fraction form. So to do that, remember, you take the denominator times the whole number times, or add plus the numerator. 8 times 2 plus 5, that becomes the new numerator. So 8 times 2 is 16. 16 plus 5 is 21. So it's 21 over 8. So really now I'm looking at what is the reciprocal of 21 over 8, right? Reciprocal of 21 over 8 is the flip-flop. If I multiply by 8 over 21, that is how I get 1. So this right here is the reciprocal of 2 5/8. Okay. So if I wanted to, I could even write then 2 5/8 times 8 over 21 is going to equal 1, because that is the reciprocal, or that is the multiplicative inverse of 2 5/8. All right. The last question, E, says check your answers by multiplying the given number with your answer and verifying the product of the number is 1. So we showed that the multiplication each time, and so the verification is there. So E is within each of the questions. Okay, there you go.